Last section of Unit 4 is really going to focus on cross-multiplying and ways that it can be used to make your life easier. So, as a quick review on cross-multiplying, because we have an equal sign here, we can draw an X through it, and we then do 5 times 24, and 8 times 15. 5 times 24, let's do it like this. It's 20, so that's 120. 8 times 15, 15 times 2 is 30. 30 times 4 would be 120. Therefore, these are equivalent ratios. Okay, it means that the two fractions are equal to each other. So, if we're looking at fractions like this, and we've decided that these are equivalent ratios, and we erase one of these numbers, so I erase the 6, and then we try to multiply through here, that means 2 times some number is going to be equal to 3 times 4, which is equal to 12. Well, we're going to write this differently now. Instead of writing it like that, we're going to write like this, 3 times 4. And even better, instead of this box, let's put a variable in there. Let's put an X. So that's what we do if we're looking for something. So we have 2 times X is equal to 12. And I'm hoping that this looks awfully familiar, because this is something that we did in this chapter. We draw a line down the middle, and we divide by 2, and X equals 6, which is what we saw earlier in the problem is the correct answer. Now down on the bottom, let's erase the 5. And we'll put an X in there instead. And we draw that through there. X times 2, well, we always like to write the 2 first, so that's 2X. And 1 times 10, well, that's 10. From here, we have to divide by 2. And X equals 5. To check your answer, all you have to do is write it back into the original problem. 5 over 10 equals 1/2. And you just have to decide if those two fractions are equal to each other. You can do that through cross-multiplying. You can do that through common sense. You can do that using decimals, whatever you decide to help you check your answer. But we know that 5 over 10 is equal to 1 over 2, so we can put a nice little check mark there. Okay, now some of you are probably looking at these and you go, well, this is just divided by 2, and I got to find some number, or divided by 5, so I got to find some number divided by 5. That works for most problems, okay? And there's a lot of times when that's a very effective way. But if we're dealing with certain numbers where maybe this is a decimal or something like that and you can't figure it out, then you have to do the cross-multiplying way. So I recommend knowing both methods. So if you can see a shortcut to get an answer, great. Use it as much as you want, no problem. But you do have to know cross-multiplying for some problems as well, or you just flat can't do it. So I'm going to try these two, and then we'll start showing some practice. So cross-multiplying through here, 4 times 10 is equal to 40. 5 times x is equal to 5x. And now we just have to divide by 5. So x equals 40 divided by 5, that's 8. To check our answer, we just plug it in, 4 over 5 equals 8 over 10. And we just multiplied by 2 to get to them, so that is correct. Down on the bottom, same idea. 8 times x, well, that's 8x. 4 times 10, that's 40. Now we divide by 8. And we get x is equal to 40 divided by 8 is 5. So 8 divided by 10 is equal to 4 divided by 5. And that is correct because we just divided by 2 on both sides. I'd like you to try these two on your own and see what you get. So for these are the types of problems when you could have some fractions built in, and that's just fine. So we get 10 times n is equal to 12. We divide by 10 on both sides. So here n is equal to 1.2. And for the first time ever, I think decimals are actually easier because fractions inside of fractions get a little confusing. So 1.2 over 3 is equal to 4 over 10. This one, to check your answer, I would multiply like this. 1.2 times 10 is 12. 3 times 4 is 12, so that checks out. Here on the bottom, same idea. We end up getting 5x is equal to 6. Divide by 5. X is equal to 1 1/5, which is also 1.2. Same idea from here. Now, I didn't purposefully give you this problem. I should have had you practice on the next one. But decimals are okay. They don't change the problem at all. Okay. Of course, if you're dealing with decimals and turning a fraction into a decimal, that is a calculator type problem. Okay, now I'd like you to try these on your own. Just to speed things up a little bit, this one is x is equal to 25. And down here, this one is x is equal to 12. If you have questions on those, make sure you ask me in class, and I can work with you on those. Okay, so now we can deal with some story problems. I think there's two. Yep. So for Mr. Schmidt drives in his car for 4 hours and he traveled 132 miles. If he drove in his car for 3 hours at the same speed, how far would he go? The easiest way to do this is to make a proportion. So I have 132 miles and I drove that over 4 hours. Now I want to know how many miles I drive, so that's what we're trying to figure out. So x miles over 3 hours. Now it's important that these matched up, hours to hours, miles to miles. You could write it a different way. You could write it as 3 hours over 4 hours equals, x miles over 132 miles. It doesn't matter as long as it matches up. You can't do the 4 and the x together because the 132 and the 4 match up. Okay, so from here, our proportion that we've created is 132 over 4, is equal to x over 3. And now we're going to solve this problem just like any other. So 132 times 3, that's equal to 396, is equal to 4x. Well, here I divide by 4. And so x equals, now I got to do a little bit of long division. So I'm going to extend the page down. So 396 divided by 4. Well, I can do 9 into 36. So that goes like this. And 36 goes down here. And that is another 9. So x is equal to 99 miles. So in 3 hours, Mr. Schmidt could drive 99 miles. Okay, big key with these, set up a proportion, make sure it matches across, and then just solve it like a normal problem. So Brendan shot 7 baskets and he made 5. If he shot 23 baskets and made the same percentage, how many baskets would he have made? Okay, so try this one on your own and see what you get. A lot of different ways to set this one up. I did 5 over 7. He shot 7 baskets and he made 5 of them. Then that's X on how many baskets he made and 23 that he shot total. It's make to make, shot to shot. And now from here, I multiply. This gives me 115 is equal to 7X. Now this is a decimal one, so I got to use a calculator. 16.4. And the question is, can you make part of a basket? No. So it's 16 baskets. Okay, if you set up your proportion incorrectly, you should have gotten a weird answer. You should have gotten, like 29 or something like that. Well, that wouldn't make sense because if you shot 29 baskets, you wouldn't, or shot 23 baskets, you wouldn't make 29 or something like that. So it's really important in these story problems to think about does this answer make sense? And shooting 23 baskets and making 16, that seems pretty realistic to me. So this answer is correct. All right, from here we have a couple assignments, quiz, and then a test.